So an aqueous solution is a compound that is soluble and does dissolve in water. So salt, table salt, does dissolve in water, and you could indicate this with the physical state AQ. But how about if a compound does not dissolve in water? For any compound that does not dissolve in water, this is called insoluble. And so insoluble, such as if you've ever put sand in water, that doesn't dissolve. And so sand in water, you could write it as the chemical formula for sand, but you would write an S for solid. Or if you have a product that's from the chemical reaction that is something that is solid and not dissolved in water, then this has a special designation which is called a precipitate, or a PPT, physical state. Okay, and that's what we saw in that first video, that yellow lead iodide. That yellow lead iodide is PBI with the physical state PPT would be the correct. So the reason why we could see the yellow is because it was a solid that was produced from the reaction. It wasn't there before. It was solid. That's why we could see it, because you can't see ions, but you can see a solid. And that is called a precipitate, when you have a product that's new from the reaction and it's a chemical change that you can see. These, which are solubility rules, to determine if ionic compounds will dissolve in water, and specifically these would be ionic compounds that are products that are created in a replacement reaction. So this is something where you need to know how to use, but you don't need to memorize. You just need to know where to find it and how to use it. And so this starts with noticing that there are 6 rules. Okay, 1 through 6. And that these are the terms that are the chemical names. So let's go through each one of these. An alkali metal compound. This means that it is in family 1A. Okay, so family 1A compounds like Na or K, those are sodium, potassium, so those are elements in family 1A. Acetates. So an acetate has this is the polyatomic ion C2H3O2 negative. So that's when you have this polyatomic ion compound present, that's acetate. The nitrate is the polyatomic ion NO3 minus. Okay, and ammonium is the polyatomic ion NH4 plus. Okay, so when you have the alkali metal, let's say for example I'll write Na plus, or if you have an acetate or a nitrate or ammonium as part of the ionic compound. So you only have to have part of the ionic compound. This could be the cation in this case, or it could be an anion, the polyatomic anion in this case and this case, or just this ammonium cation in this case. That makes this soluble, and so this would get the physical state AQ. Okay, so that's the interesting thing about ionic compounds. If one of the ions will dissolve in water, then both of the ions have to dissolve in the water and become an aqueous solution. Okay, so soluble means write AQ for the physical state. So rule 2 says that hydroxides of alkali metals. So first, hydroxide is the polyatomic ion OH minus. And it has to be a hydroxide that's bonded to an alkali metal. So this is part of the ionic compound, has to be the alkali metal, and those are in family 1A, like the sodium. So, or you could have the NH4 plus, that's the ammonium compound, or the calcium ion, or the strontium ion, or the barium ion. These are all soluble, so this would be writing an AQ physical state. Okay, so for example, if you have NaOH, that would get the physical state AQ because it is the hydroxide with an alkali metal. Okay, but if you have a hydroxide like MgOH2 with this hydroxide, is not the alkali metal or ammonium or calcium or strontium or barium, that's insoluble. And insoluble means you would write an S or a PPT, physical state. How do you decide between S or PPT? Remember PPT. Okay, so I'll write it down here, S or PPT. PPT is only on the product side. So it is when you have a product that is insoluble. So for example, if this was on the right side of the arrow, you would write MgOH2 with a PPT, okay, if it's on the product side. Okay, so that's rule 2. Now let's look at rule 3, which says that halides. So halides are halogens. Those are in family 7A. So for example, chlorine in family 7A, and it's not a halogen if it is an anion, so this is an IDE ending, so chloride instead of chlorine. So chlorine, fluorine, bromine, those are the anions, chloride, bromide, fluoride. Okay, so those are soluble, so those would get the AQ. But there are exceptions, except for those containing Ag+, Pb+2, and Hg2+2. So this is the silver ion, the lead 2 ion, and the mercury 2 ion, which we have not talked about the mercury 2 ion, so you don't need to worry about that, but we do have the silver ion and the lead 2 ion. So for example, if you have this as, let's say, KCl, so anytime you have Cl, that's half of it, that's the chloride part, this is going to be soluble, okay? But there are these exceptions, such as AgCl. So if the chloride part has the Ag stuck to it, that means it is not soluble. So this would be a solid, or if it's on the product side, it's going to be written as AgClPpt. Remember, precipitate is going to be on the product side. Rule 4 says that most sulfates are soluble. So a sulfate is the polyatomic ion SO4 with a -2 charge. Okay, 2 minus or -2. So that means that if you have this polyatomic ion, this is going to be soluble, which is AQ, but these are exceptions. So let's write the example of something soluble, which would be Na2SO4. The 2 comes from the sulfate and crossed over and down to become the subscript for Na. This is soluble, but these exceptions, BaSO4, SrSO4, etc., for example, PbSO4, this would be written as a solid, or if it's on the product side, PbSO4, which would be a PPT. So that would be a product created from the reaction. And then in rule 5, you have phosphates. So phosphates are the polyatomic ion PO4 3-. Carbonates, that's the polyatomic ion CO3 2-. Chromates are a polyatomic ion that we don't need to worry about. And sulfide is when you have the sulfur anion, IDE, that's a monoatomic, so that's sulfur forms the -2 anion because it's in family 6A. These are all insoluble, okay? So an example would be if you have MgPO4, where this would be a 3 and a 2 subscript. These are insoluble, so this would be an S, or if this were on the product side, Mg3PO4 2 PPT. But that is insoluble unless you have rule 1, which is an alkali metal or ammonium. Okay, so for example, if you have Na3PO4, this would be an AQ because you have the alkali metal attached to the phosphate. Okay, so that would be true about the carbonates and the sulfides as well. Rule 6 says that all acids are soluble. Acids have hydrogen as the cation. So hydrogen is always going to be the first element. So for example, when you have HCl, hydrogen is the first element. This is soluble and that gets the AQ. Okay, we're going to talk about acids in the next chapter, but we will see acids in the upcoming reactions.